For a technological civilization born on a planet as massive as Earth, the easiest way to engage in high-speed interstellar travel might be to hitchhike. Over the past decade, we discovered several interstellar objects, the biggest and fastest of which is 3I Atlas. This is a brightness map of the projected jet structure around 3I Atlas, observed on January 14th, 2026 by the Hubble Space Telescope. The image was processed through a Larson-Sekanina rotational gradient filter, which removes the circularly symmetric glow around the nucleus. The three mini-jets are nearly equally separated from each other and are supplemented by a longer anti-tail jet in the sunward direction. And here you can see the jet system is wobbling periodically with a period of 7.2 hours around the rotation axis based on two Hubble exposures separated by 23 minutes on November 30th, 2025. An abundant population of objects like 3I Atlas, which are larger than a kilometer and faster than 60 kilometers per second, could be viewed as vehicles for interstellar travel. They take less than 1 billion years to reach stars on a ring around the center of the Milky Way galaxy. 9 days after its perihelion approach, on October 29th, 2025, 3I Atlas was observed for 32 days by the all-sky hydrogen Lyman Alpha camera on board the Solar and Heliosphere Observatory. The camera detected a massive plume of hydrogen around 3I Atlas, implying the release of 13.5 million metric tons of water during the month of observations. Hitchhiking a water-rich object like 3I Atlas offers the benefit of using electrolysis to break water molecules into their constituent hydrogen and oxygen, which serve as efficient rocket fuel. A system of thrusters can use the fuel to navigate towards desired destinations, like the orbital plane of planetary systems. SOHO may have detected some of that hydrogen fuel. A hitchhiked interstellar object could also account for geometrical oddities, such as the 5-degree alignment between the trajectory of 3I Atlas and the orbital plane of the solar system planets, the alignment of its rotation axis with the direction of the sun at large distances, the symmetric jet system of 3I Atlas, as well as composition anomalies, such as the anomalously high nickel-to-iron ratio on the background of familiar cometary outgassing. Embedding a technological object inside a cometary exterior has the benefit of masquerading the equipment as a natural object and avoiding risks from outsiders, akin to the benefits offered by the Trojan horse in Greek mythology. Naive observers throughout the Milky Way galaxy would mistake these hitchhiked vehicles for natural objects at first sight. However, highly intelligent scientists might notice subtle anomalies as flags of technological signatures. These scientists are most likely to be ridiculed by their colleagues at first, until their civilization decides to launch interceptor missions that study interstellar objects from up close. A close-up camera might reveal the infrastructure and power source that generate the electricity needed to convert water into hydrogen and oxygen fuel and enable activities by the passengers on the vehicle. What might be the technological fingerprints on an interstellar comet? They could include 1. Excess heat from an engine, potentially detectable by infrared sensors like the Webb Space Telescope. 2. Unusual maneuvers that cannot be explained naturally. 3. A system of thrusters in design configurations. 4. Artificial lights. 5. Release of mini-probes in strategic locations. The detailed constituents of the payload depend on the goals of the interstellar mission, which reflect the ambitions of the senders over periods of billions of years. As in any blind date, it would be wiser for us to observe the interstellar package rather than second guess the motivations of its senders over the huge space-time horizon that they contemplated. Finding an interstellar vehicle of this type might motivate us to hitchhike natural interstellar objects for the same purpose. If we decided to hitchhike our way to interstellar space, what would we need to do? After discovering a suitable vehicle on its way towards us, we would need to deliver a payload that includes suitable power supply and technological equipment into a path that crosses the trajectory of the desired interstellar object at a sufficiently low impact speed so that the payload will not get damaged during the delivery. It would also make sense to endow the equipment with artificial intelligence, since the light crossing time across the Milky Way disk of stars is of order 50,000 years, making it impractical for the traveling equipment to get real-time guidance from the senders. Biological brains are far more vulnerable to the hazardous conditions in interstellar space than technological brains. This is why I titled the recent essay, What if 3i Atlas is AI/Atlas? Given this perspective, it makes most sense to keep monitoring 3i Atlas in the coming months, including after its passage close to the Hill radius of Jupiter on March 16, 2026. The extraterrestrials should be pleased if others imitate them. As Oscar Wilde noted, imitation is the sincerest form of flattery. If interstellar hitchhiking happens to be a popular trade among technological civilizations, then we might find out after landing our equipment on a passing interstellar object that it already has some alien equipment. In that case, we might join the aliens in their endeavor and read from their travel journal all the highlights of their journey thus far.